Today, we will talk about the simple linear regression. We have constructed the scatter plot between our studied and exam grade. Based on 5 data points, we see there is a positive correlation between our studied and exam grade. And in fact, we can summarize this scatter plot using a straight line. Now the question is that how to find this straight line, and we call it the best fitting line. How to compute the regression line? Here the x-axis indicates our studied and the y-axis indicates exam grade. We can use one line to summarize the relationship between these two variables. But we can draw this pink line, or we can draw this blue line, or we can draw this red line. So which line best represents the data points? Here we learn how to compute or how to find out this best fitting line. Let's see if this red line is the best fitting line. And for each data points, suppose let's look at these data points. Now each green dot is the real data points, and it presents the real y value or the exam grade the student received. Suppose we erase these data points. Who studied 30 hours? We erased it. Then if the student studied 30 hours, then using this red line, we predict that the student would receive 100. Then let's put back the true data point, which is the green one. The red one is the one we predicted, so we indicate it by y hat or predicted exam grade. The green one is the true exam grade. Then when we make the prediction, we make some error. So the student received 88, but we predict the student would receive 100 if he studied 30 hours. And this discrepancy is the error we made. For each individual data point, when we make predictions, we may make some errors. This would happen to each data point, as long as it does not sit on the red line. If the data points deviates from the red line, when we use the red line to predict their exam grade, we will make some errors. The errors are indicated by this black line I'm drawing. Sometimes we make small errors, sometimes we make big errors. So how to find the regression line? The rationale is that we try to find that line that minimizes the errors between extra y, the green points, and the predicted y hat, the red points. This line is written as y hat equals to bx plus a. X change along the x-axis, y change along the y-axis, but the line is fixed because we define the line using b, which is indicating the slope of the line, and then the intercept a, which is the y value when x equals to 0. So the regression line y equals to bx plus a plus error, which is y hat plus error. Now, if we understand the rationale of choosing the best fitting line between x and y, let me ask you a few questions. First, how to define this best fitting line? That is, you want a line predict the errors. Error equals to the true y minus y hat. And you want a line that minimizes the sum of the squared errors. So if you use each y minus each predicted y, then you square them, then you add the squared errors together. This sum of the squared errors should be the smallest. Therefore, the regression line with the best fitting line is also called least squares regression line. My second question is, what is the general equation of a regression line? This is easy. It is y hat equals to bx plus a. The third question is, what is the property of a regression line? Okay, the property of this regression line is that it always crosses the point of x bar and y bar. Okay, so the mean of x and mean of y, this line always crosses that point. Now we have defined the best fitting line. The next question is how to compute a best fitting line based on dataset. The best fitting line is indicated by y hat equals to bx plus a. We know that x changes along x-axis and y changes along y-axis. Those are the two variables. To find the best fitting line, we need to find b and a, the slope and the intercept. This defines the specific line we need. The formula for b, or the slope, is the covariance between x, y divided by variance of x. And we are familiar with those things. We've done this many times. Then from b, we can find out the intercept. Here are the formulas. Remember, the property of this best fitting line is that it always crosses the point of x bar and y bar. That is, y bar equals to bx bar plus a. Then if we switch the right and the left, bx bar plus a equals to y bar. Then if we move bx bar to the right, the intercept equals to y bar minus bx bar. So that is the formula for the intercept. A equals to y bar minus bx bar. Now let's compute the regression equation y hat equals to bx plus a. We need to find out the slope and the intercept. Here is the data set. And based on the data set, here is the scatter plot between SAT and the GPA. The regression line. So let's see what is the slope and the intercept of this regression line. The slope equals to covariance of x and y divided by variance of x. So we need to first find out mean of x. It is 616. Then find out the mean of y. It is 3.2. Then we subtract the mean of x from each x. We will have 14, 84, 174, negative 106, and negative 166. Next, we subtract the mean of y from each y. We will have negative 0.2, 0.3, 0.8, negative 0.2, and negative 0.7. We multiply these two columns together, we will have negative 2.8, 25.2, 139.2, 21.2, and 116.2. We add these five numbers together. This will give us SSXY, or sum of squares, sum of the cross product. It is 299. Covariance equals to 299 divided by 4. It is 74.75. The last column presents the squared deviation scores of x. So it is 14 squared, which is 196, 84 squared, which is 7,056, 174 squared, we have 30,276. Then we will have 11236, 27556. We add these numbers together, we get the sum of squares of x, which is 76320. SSX divided by 4, we have 19080. That is the variance of x. Slope equals to covariance divided by variance of x. We have 0.004. Then we get the intercept. Intercept equals to mean of y minus b times mean of x. So mean of y is 3.2 and the mean of x is 616. So slope is 0.736. Therefore, the regression equation is y hat equals to 0.004 times x plus 0.736. As we mentioned, the slope is the intercept is the value of y when x is 0. So when x is 0, y equals to 0.736. Then we also mentioned that this line always crosses the point of mean of x and the mean of y. We know mean of x is 616 and the mean of y is 3.2. So the point of mean of x and the mean of y sits on the line. Then using this line, we can make predictions. Suppose somebody received 500 on SAT verbal, so x is 500. Using the line, we can predict that this person may get a y hat about 2.7 or 2.8. We can use the regression equation to compute y hat. Y hat equals to 0.004 times x, which is 500, plus 0.736. It is 2.736. So that is a predicted GPA if somebody scored 500 on SAT verbal score. Now I have a couple more questions. Question 4. What is the function of a regression line? Why do we need to compute this regression line? The function of the regression line is that with a given x, we can predict y. Regression line is used to make predictions. Question 5. What is the problem of using a regression line to predict y? The problem is that when we make using the regression line to make predictions, we make errors. Error equals to the true y minus the predicted y. Error has many names. It calls error. It also sometimes called residue. And sometimes it was called disturbance. So it's the same thing, error. So if you understand how to compute the regression line, you can take out in-class exercise 2.1 from Canvas. There are 5 questions on in-class exercise 2.1. You can start working on question 1 and 2. After you finish question 1 and 2, you can resume the lecture.